Now sketch the graph of the following function. Now we are given this four function to sketch the graph. So now let's work it out. Now starting with the first one, you have the first one a is x minus 2 all over x. So now let's assume you have y is equal to x minus 2 all over x. Now to solve this, now let's now work things out now. Now for the condition where y is equal to 0, let's find some of these boundary conditions. So y equal to 0. Now if you now say y is equal to 0, that is 0 is equal to x minus 2 all over x. Now if you multiply both sides by x, you have 0 equal to x squared minus 2. So that means x squared is equal to 2. So taking the square root of both sides, you have x is equal to plus or minus the square root of what? 2. Taking the square root of both sides. Now we have gotten the condition where the boundary condition where y equal to 0, x will be equal to plus or minus square root of 2. Now let's look at another boundary condition. Another boundary condition where x is equal to 0, y will be equal to what? Now let's say with the minus part of 0, if x is equal to the minus part of 0, you have y to be what? Um, plus infinity. Now we also have, if x is equal to the positive part of 0, you have y to be what? Y to be what? Minus infinity. So now we also have to go into other details now. Let's look at the stationary points. So now you have the y all over the x. To differentiate this, you have the y all over the x equal to 1 plus 2 all over x squared. Now at the point where the y all over the x is equal to 0, we have 0 equal to 1 plus 2 all over x squared. Now if we multiply all through by x squared, you have 0 equal to x squared plus 2. So that means x squared is equal to minus 2. So here the root of x here is an imaginary number. So since it's an imaginary number, it means there is no stationary real point on this curve. So now we will now consider, now we have gotten this, then now so there are two boundary conditions we are to use now. Now we have three boundary conditions. This is one, this one is 1, this one here is 2, here is 3. Now there is another one, the fourth one. Now if x is equal to minus infinity, y will be equal to what? Okay, y will be equal to minus infinity. So if x is equal to plus infinity, y will be equal to plus infinity. So there is a boundary condition here also where y is equal to x. So you look at it now, this one, the condition is that y is equal to x. So on that line, the curve will be tending, so that the line will be, the curve will be, the graph will be tending towards that line. So now let's draw the line. Let's draw the curve. Now, at the point where y is equal to 0, you have first one minus square root of 2, the second one plus square root of 2. So then where you have x as negative 0, you have y tending to positive infinity. So that means the line moves towards the side. Now where you have x as positive, the y tends towards negative infinity, so this way. And the line passes through here. You also pass through here. So you see this one joins like this, and this one joins this one. Now there is a line that the line also tends towards, is y equal to x. So y equal to x. So let's say this is the line y equal to x. It passes through origin because y equals to x, where x is equal to 0, y is equal to 0. So passes through the origin. Now that means this curve will now tend towards this line, and in this other side it will also tends towards the line. So this is a curve. So this is going this way. Let me draw this well. This is the y-axis. So here is plus the square root of 2. So passes through this place like this and like this. So it tends towards. So this is the graph. Now let's look at the next one. The next one you have b, which is y is equal to x cubed minus 3x squared plus 3x. So now let's now look at the condition where x is equal to 0, y is equal to what? 0. Now we're looking at the boundary condition. So now where y is equal to 0, if you put 0 here, you have x cubed minus 3x squared plus 3x. So now you have x, you factor all, x is common, so we factor it out. So now you have x squared minus 3x plus 3. So we have, so now if we use quadratic formula to solve this, where you say, now to solve, let me do it here. You have x squared minus 3x plus 3. Now if you use the quadratic formula where you have minus b plus or minus the square root of b squared minus 4ac all over 2a. Now you have b to be equal to minus 3. So you have 3 plus or minus the square root of 9 minus 4 times 1 times 3, c is 3, divided by 2. So we have 3 plus or minus the square root of 9 minus 12 divided by 2. So this is an imaginary number. So there is no stationary, so there is no stationary points. There is no, here does not have a point where y is equal to 0. So the only condition here is, the only condition is x equal to 0, which is this one. So that is the only condition. Now let's look at the stationary points. Now let's differentiate that. We have said dy all over dx is equal to what? 3x squared minus 6x plus 3. Now, so dy dx is what? 3x squared minus 6x plus 3. So the stationary point is where your dy dx is equal to 0. So we'll now say 3x squared minus 6x plus 3 is equal to what? 0. So we can factor them out. 3 is common. You see, just divide all through by 3. So you have x squared minus 2x plus 1 equal to 0. So this is the same thing as x minus 1 all squared equal to 0. So that means we have x equal to 1 twice. So since it's twice, now let's further differentiate to get the derivative, second derivative, to know the nature of the stationary point. So now you have the square y over the x square will now give us what? 6x minus 6. So the square y all over dx square at x equal to 1 will be what? 0. So that means this stationary point is point of what? Inflation. Now, since the square y all over dx square is equal to 0, it then means that, now, if you consider here now, if you have x equal to 1 on the negative side, that is the negative side, which is, let's say, 0.9. You put 0.9 there to still give you a positive value because you have the square here. Now, if you put x equal to 1 plus, which is 1.1, it will still give you a positive value. So that means dy dx at this point, what happens? It increases. So it has a slope up like this at this stationary point. At this other side of the 1, you also have a slope that goes up. So that is it. So now, you look at it, this is positive. So if you put minus 1 negative, that means you have, like, if you subtract, let me 0.1 from here, you have 0.9. If you put it here, Here will give you a negative value, but if you square it here, it becomes positive. That means the y dx is positive here. Same here. So that means the curve will move this way at this point. Now, at x equal to 1, what will be your y? Now, we have y to be equal to x cubed minus 3x squared plus 3x. So now, if x is equal to 1, that means y will be equal to what? 1 minus 3 plus 3, which is equal to 1. So that means when x is equal to 1, your y is equal to 1. This is another condition, the boundary condition. Another boundary condition here. Now, we can use this whole thing to draw the graph. So the graph now will now look something like this. Now here is 1. Here is 1. Now where y is equal to 0, x is 0. See it? So at the origin, because it's the first condition. Now, so this origin. So that means it goes like this, comes this way up. Now here, it will not be like this, and also goes up like this. So this is the way the curves moves like this, and this other way up. So at this point is a point of inflation. So we have been able to draw that curve. So now let's look at the next one. The next one, you have c equal to x plus 4 all over x. So we have y to be equal to x plus 4 all over x. Now, if for instance we say, so we have y equal to x plus 4 all over x. Now, where y is equal to 0, what is your x? Now, let's look at the boundary conditions here now. So we have 0 equal to x plus 4 all over x squared. Sorry, all over x, sorry. So if you multiply all through by x, you have 0 is equal to x squared plus 4. Now, x squared is equal to minus 4. So this will give us an imaginary number. So there is no real root here. So in essence, y, there is no condition where y is equal to 0. It means that the graph did not touch the x-axis. Not touch the x-axis, yes. Now, since it did not touch the x-axis, let's look at when x tends to what? When x is equal to negative 0, what will be your y? My y now will be y is equal to negative 0 plus 4 negative. So now we have negative minus infinity. That is what you will have. So you have y will be equal to minus infinity. This is another condition, boundary condition. Now, if x is equal to 0 plus That means we have our y to be what? Plus infinity. So we've gotten this. Now another condition. Now if x is equal to minus infinity, y will be equal to what? Y will be minus infinity. So if x is equal to plus infinity, y will be equal to plus infinity. So here is a condition where y is equal to x. So and this other condition is an inverse condition. Here is an inverse condition. So now we will now have to also find a stationary point. So dy all over dx will give you what? 1 minus 4 all over x squared. Now let's look for stationary condition where we have dy dx equal to 0. So we have 1 minus 4 all over x squared equal to 0. Now, so where you have 1 minus 4 all over x squared equal to 0, if you multiply all through by x squared, you have x squared minus 4 equal to what? 0. So let's move this x4 to this other side. You have x squared equal to 4. So the square root, squaring both sides, taking the square root of both sides, you have x equal to plus or minus 2. Now, so we have stationary point at plus 2 and what? Minus 2. So let's look at what is the nature of this stationary point. So now do the second derivative. So dy d square y all over dx square will give you what? Will give you minus 8 all over x cubed. No, it will now be plus 8 over x cubed all over from plus 8 all over x cubed. So now let's look at what for x equal to 2, the square y all over dx square will give you what? Will give us 1 plus 1, meaning this is greater than 0. So that is minimum point. Now for x equal to minus 2, you have the square y all over dx square equal to what? Minus 1. So this is less than 0. So this is the maximum point. So now with these conditions, we can now draw this graph. Now, to draw this graph, it doesn't have the point where y is equal to 0. There is no point where y equal to 0. So where x is negative, you have negative y. So this place you have negative y. Now at minus 2, you have maximum. So it's something this way. Now there is also this way. Now here is 2, you have minimum here. So and also where you have positive side of 0, you have positive infinity. So which is this way like this. Now there's also condition where you say, okay, let me just erase this. Now let's now draw a line like this. This is y equal to x. Now here you have positive y infinity close to x. Then here you have minimum point, minimum. Then it also tends towards y equal to x. Just the same with this. So this is a graph. So we have put the graph. You have it this way and line x. Then here this way and then line x. So that is a curve. So don't mind my drawing. The freehand sketch. So this line is y equal to x. This is so that is it. Now let's now do the last one on the list. You see the b part, you have x squared minus 3x plus 4. That means y is equal to x squared minus 3x plus what? 4. So at the point where you have y equal to 0, what is x? That's, we look at the boundary conditions first. Say x squared minus 3x plus 4 is equal to what? 0. Now x squared minus 3x plus 4 is equal to what? 0. So now let's make use of so we have 2 now, 4 now. Sorry, here it's supposed to be minus. Well, let's work this out now. Using this, you don't have with this. Now let's now apply quadratic formula. You have a to be equal to 1, b to be equal to minus 3, c to be equal to 4. Now x will now be equal to minus b plus or minus the square root of b square minus 4ac all over 2a. So we have 3 plus or minus 9 minus 4 times 4 2. So this one is an imaginary number, so no real roots. So there is no point where you have x where you, so that means this curve does not touch the x-axis. Now let's look at if you have a stationary point, you have d y all over dx equal to what? 2x minus 3x. So we have 2x, sorry, minus 3 minus 3 2x minus 3. So at the point where you have dy dx is equal to 0, so that means you have 2x minus 3 equal to what? 0. That is the implication. You have 2x is equal to 3, x is equal to 3 all over 2. So So at the point where x is equal to 3 over 2, that is a stationary point. Now at this point, what is your y? If you substitute y x into this equation, we look for your y. So now y will now be 3 over 2 square minus 3 divided by 3 over 2 plus 4. So we have 9 all over 4 minus 9 all over 4, 9 all over 2, sorry, plus 4. So this will now be, y will now be 9 minus 18 plus 16 divided by 4. This. So we have this plus this is 25 minus 18. 25 minus 18. That's 7 all over 4. Y is 7 all over 4. So now where x is equal to 0, so what is your y? Y will be equal to 4. So these are conditions. Now let's make our sketch. Where x is equal to 0, y is equal to what? 4, somewhere here. Let's say 4 is somewhere here. So that means the graph passes through 4. Now let's look at, you have dy dx equal to 2x minus 3. So now let's look at the condition. What is the nature of this? Now to get the nature of it, we differentiate this further. D square y all over dx square will give you what? 2. So this is greater than 0. So that means it's minimum at this point. So at that point, 3 all over 2, this is somewhere, let's see, have 1 here. 3 all over 2 is somewhere here between 2. So this is 3 all over 2. And at that point, you have y to be 7 all over 4. 7 all over 4. That is, you have something, you have 1 here, you have 2. So in between here, you have 7 all over 4 somehow. Now let me say here is 3, here is 4. So let me say it cut across the y axis at this point. Now and also at this point is where you have the stationary point. So now it will not be like this. Now and also goes up, because you see it doesn't touch the, because it has an imaginary root, so it doesn't touch the x-axis. So this is the way the curve goes. So this is the curve. So now that is it. So this is a final. Thank you for watching to the end. Have a nice day. Also do well to subscribe to this channel, to my channel, so that when next I make new video, you'll be the first to watch. Thank you and God bless.